Now, the age of the Terminator isn't upon us, but researchers in America have created the world's first living robots, and they've been based on a type of African frog. They're known as xenobots. They are created by using stem cells from frog embryos. This is the process of their creation, and it's hoped that they will be used in medicine and some underwater research. Now, these living robots are tiny in size. They are 0.04 of an inch. Well, let's speak now to computer scientist and robotics expert Joshua Bongard, who co-led the breakthrough and joins me now from Vermont in the United States. Good afternoon to you. This is a very exciting development, the first living and self-healing robots. Talk us through the process of how they were made. It all started with a humble frog.
Sure. Yeah, thanks for having me on the show. As you mentioned, it starts with the humble frog. And before we actually build any of these xenobots, we start with the supercomputer here in Vermont and ask the AI to put simulated frog skin cells and frog heart muscle cells together in a configuration so that the final simulated biobot does what we want it to do, which in this case was simply to crawl along the bottom of a simulated petri dish as quickly as possible. The supercomputer worked on that for a few weeks, and at the end of that period, it gave us back a winning design. And our microsurgery colleagues at Tufts University here in the US then built up the design dictated by the AI from actual frog cells, as you mentioned, taken from an embryo. And the result is a grain of sand-sized biobot that, when we placed it at the bottom of a real petri dish, moved in the same way that the computer predicted it would.
Yeah, it's so interesting. These biobots look nothing like you would expect a robot to look like, because when you think of robot, you think of metal, you think of shiny arms. This looks like a living organism. What is it about it that makes it robotic?
So it's a robot in the sense that it's something that was created by humans, although indirectly through a computer. And the result is, in essence, a machine. It's just a machine that's built from cells rather than a machine built from more traditional components like metals and plastics and electronics.
Joshua, what can they do?
So at the moment, they don't do much. As I mentioned, the AI designed them to move along the bottom of a petri dish. But one of the things we found interesting in this study is when we actually built multiple instances of this one design and created a small swarm of these biobots and put them back in the dish along with some even smaller pellets, the swarm as a whole acted like very small sheepdogs. They pushed the pellets into neat little piles, which suggests in future they may be able to help with environmental cleanup jobs like removing microplastics from the ocean.
Yeah, it's interesting, isn't it? Because they are so tiny and you're still at a very early stage with all of this. What do you hope that they will be able to do? You mentioned they're sort of cleaning up waste. What other things could they possibly do as developments go along?
Sure. Yeah, so as I mentioned, I think there may be some environmental applications. One of the nice things about this particular technology is it's 100% biodegradable and biocompatible. So the other obvious set of applications are clinical applications. So there's a lot of work in robotics, traditional robotics, to make very small micro robots, which might someday be swallowed in pill form and intelligently deliver medication exactly to where it needs to go inside the human body. The problem with that is that the human body really detests small amounts of metals. So we're hoping that our clinical colleagues might be able to develop this into a xenobot-based intelligent drug delivery system.
So it could help with regenerative medicine in the future.
That's correct. So not only might it actually help to deliver medication to, for example, a cancerous tumor, but it might in turn also help us to understand runaway growth like cancer itself. We can use these small biobots not as machines, but as a new scientific instrument, not unlike a telescope or a microscope.
Well, Joshua, it's been fascinating to talk to you. Thank you so much for talking to us about your breakthrough development. Joshua Bongard there, robotics expert who co-led this breakthrough. Eco-friendly robots, there you go.